right, I haven't had to make a video in a long time this way. Let's see how I do. I predict I'm going to bump into this a gazillion times because I have it too probably close. Let's back it up. Let's see. Okay, so this lesson is for tomorrow. Tonight's Thursday, tomorrow's Friday. We're doing scatter plots, correlation and trend lines. This should be a review. And then we're going to do an activity on Monday that goes with this, like a stations activity, something like that. So it says the following data represents the height of a premature kitten in inches over several weeks. So you can see the table, weeks, so 1 week, 3 week, 5 weeks, 7 weeks, 9 weeks, height in inches, 2.1, 3.1, 4, 5.2, 5.9. It says decide whether a linear model is reasonable. If so, draw a trend line and write its equation. So the thing about scatter plots is a couple things that are important. We need to have values on our x-axis and values on our y-axis. So I copied this on, you can kind of see the light grid behind it. That's on purpose so that you kind of have graph paper behind it. I'm going to call this x and this y. The x are the weeks. So we're going to call this weeks down here. And this is the height in inches, so you can turn your paper sideways or you can write it the other way. Height in inches. And then we need to make a decision about the increment. So 1, 3, 5, 7, 9, to me it just makes sense to go by ones. So I am literally going to go, like I can see the lines below there. That's 1, 2, 3, 4. I'm not skipping any spaces. 5, 6, 7, 8, 9. So those perfectly match up with the graph, the grid lines. Okay. Looking at the height, it's 2, 3, 2-ish, 3-ish, 4, 5, 5.9. So I'm actually going to just go by ones on here, sticking with the same thing. I'm just going to stick with the grid lines. 1, 2, 3, 4, 5, and 6. Okay, when in doubt, just go by onesies. Okay, we're going to plot the points that they give us. And some people tend to plot their points too big, and then it's less accurate. So we're going to try to be super accurate here. So the first coordinate is at week 1, it's 2.1. So week 1, 2.1 is just barely above the 2. So I don't even know if you can see my point there, but it's pretty small. All right, the next one is at 3 weeks. We're at 3.1, so just above the 3. At 5, it's a perfect 4.0, like some of your GPAs. At 7, it's 5.2. So 5.2, a little bit higher than the 0.1s. And at 9, it's at 5.9. So at 9, 5.9, so just under where it would be a 6. So can you see my dots? You can zoom in if you can't. So you make sure you get your dots in a good spot. So the question had asked, decide whether a linear model would be reasonable. So if a linear model is reasonable, you can kind of tell, is the scatter plot, is it going in the same kind of direction? Are all the dots kind of lined up? We call that correlation. So because as you're going in farther in weeks, the height is going up. So they're kind of going together in a positive correlation. If the dots were coming down together kind of in a linear way, it would be a negative correlation. And if they're scattered all over the place, then it's no correlation. So you probably remember that from a previous class. But these do look like they have a correlation. In fact, it looks like a positive correlation. I'm going to write that out here, positive correlation. Okay. And it does look like a reasonable model would be a linear model. Okay, so that's where a trend line comes into play. So how you draw your trend line is important. You can't just draw any old line. Like if I put my pencil down there, that would not be a good trend line because it's not really going in the direction of the points. You want it to follow the trend, right? The trend is it's going up like this. Now, I can't draw a line that fits all these points exactly because they're not perfectly on a line. See how it's kind of twisting and then at the end it turns this way? So I can't draw one line through all of those points, but I can try to draw a line that lands as close to perfectly in the middle where the same number of points are above it as below it to the best of our ability. Sometimes that line will hit a few of the points, sometimes it won't, but you're just trying to do the best you can. So I'm going to give this a shot, okay? So I'm going to try to draw this line, and I did bust out a ruler. You guys can use your ID cards or something, and I would use a pencil because sometimes it doesn't work out so good. So you got to try to do it. So like if I went right here, I'd end up with maybe 1, 2, 3 above, and there'd be 1 below. So I've got to tilt it a little bit. I'm trying to get it as close to perfect as possible. So sometimes you just got to go for it. I'm going to go for it here. Whoops, I kind of off at the end, it kind of fell off, didn't it? Oh, and of course this eraser doesn't work. Oh well, we're just going to go with it. Okay, so mine actually hit like 3 of the points almost right on. I've got 1 above it and this one is just a little below it. Okay, but that's not a bad trend line. It would have been a little bit better if this one was a little closer, but it's pretty close. It's not too bad. So that's the goal, is to try to get the even number above below. And it kind of has that. I have 1 there and 1 there. So there's my trend line. Okay. But now I have to write its equation, and this is the part where most of you are going to struggle, even though you've been writing equations of lines for years and years. I know you have, because I was just helping that 8th grade student the other day, and she was doing this exact lesson, exactly, having to write equations of trend lines. So here we go. So remember that the equation of a line, we're going to use the good old most popular one ever, y equals mx plus b. So our job is to figure out the m and the b, and maybe you remember what those are. I hope. We've done it lots of times this year. The m stands for the slope of the line, and the b stands for the y-intercept. And we're not just going to guess at it. We're going to figure it out using all the tools we've used this year. Okay? So to find those 2 things, we are going to identify 2 points, 2 coordinates that are on the line. They have to be perfectly on the line. And we want good ones, like that land perfectly in a corner. So coming back up here, I'm trying to find ones that, like with the grid lines right below it, that seem pretty darn close to perfect. So I'm going to circle this one. Remember, that was the 5, 4. It was actually one of the original points. That one is a really good one. So 5, 4. And then I'm trying to find another one that's pretty perfect. I don't see another one that's really perfect. The closest one I can get is this one. Does that one sound reasonable? Now, it's not perfectly on the corner. That one is one of the ones that came from the chart also. It's 3, and remember it was 3.1. So if you can use perfect ones, great. If you can't, you use the ones from the table that the line actually went through, but they have to be 2 points where the line actually went through it. So I want you guys to circle what you use when you do this so I can see it, and those coordinates should go with it. Okay, now to find slope, if they were perfect, we could count that slope, rise over run, but we're going to use our slope formula, which is subtract the y's over the x's. We've done that lots of times this year, so it's nice that we're revisiting it. I'm sure it was all over the state test, and it was probably also on the PSAT. So here we go. Remember, this is an x and a y, an x and a y. So when we do this, we're going to subtract the y's on top. The order does not matter. I know it says y2 minus y1, but it doesn't matter. I'm going to do 4 minus 3.1. The important thing is whatever you do with the y's, you go that same order with the x's. So 5 minus 3. Oh, great. Of course, there's a cloud going over the sun, so we can't see as good. So on bottom, 5 minus 3 is 2, and 4 minus 3.1. Let me turn some lights on here. Hold, please. It's a little better. So when you do 4 minus 3.1, and you can do that on a calculator if you want to. I'm doing it off to the side, old style. It's 0.9. I thought it was. I just didn't want to make a mistake during a video. You know what I'm saying? So that is 0.9 over 2. That's really bad etiquette, though, because we never want to mix a decimal and a fraction together. So I am going to stick with fractions because fractions are always more accurate. You might disagree. You might want to do decimals, but I'm going to do fractions. So what I'm going to do is this. I'm going to move that decimal over. So that's going to be a 9. But what we do on the top, the decimal would be behind the 2. We have to do on the bottom. So that would be 9 over 20. So there's our slope. You may not like that, but whoop, there it is. So I'm going to come back over here. We have y equals 9 over 20x plus, and we need to know what the b is. We've done this again a lot this year, just not recently. So how do we get that b? Hopefully you guys are starting to remember this. To get the b, we can use either of these 2 points and plug them in and solve for b. I'm going to choose to use the easier of the two. I'm going to use this x and y because they're nicer, the 5 and the 4. So I'm plugging those in. This is 4 equals 9 over 20, the x is a 5, plus b. And we have an option here. We can cancel the 5 and the 20, which is one of my favorite things ever, and work with fractions, or we can cancel the 5 and the 20, and then we can get rid of the denominator. That's what I'm about to do. Sometimes you can't cancel these, but in this case you can. So 5 goes into 5 once, 5 goes into 20 4 times. So the 5 is gone. 4 equals 9 over 4 plus b. I want to get rid of this 4. So we've done this all year long. When we want to get rid of something, we're going to times by 4 all the way across. And we have to do it to everything, including the b right there. So 4 times 4 is 16. The 4 is going to cancel with 4 and have a 9. And then we're going to have 4b. We can subtract the 9 over. And 16 minus 9 is 7. And then we have to get rid of the 4. So divide the 4 over. And b is equal to 7 over 4. So our trend line, final answer, dun, 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 y equals 9 over 20. Here comes a kitty cat. Going to jump up here because he's not allowed on the counter, but he knows I'm busy. 7 over 4. I'm going to give you a little, see, Tommy, look, it's Tommy. And I dropped the phone. See, you're not allowed on the counter. You're supposed to be down. Huh, say, but I like people. Okay, so there's the answer. Y equals 9 over 20, x plus 7/4. That is the equation of our trend line. So we can look to see, get down, Tom, 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 go, go, go. Go, 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 go. He didn't go. I'm trying to see if that looks reasonable. So this is where it's hitting, whoops, too close, too close, too far, too far. This is where it's hitting the y-axis. There's 1, there's 2, 7/4. Isn't that make sense that it hits right before 2? Because if I did 8/4, it would be 2. So it makes sense that it's hitting right there. So that is an actual really good trend line for this equation. All right. Hope you enjoyed it. Bye.